Hello, Doctor. Today I will talk about my project from the last year, which is the Galileo clock. First, I will present a short presentation, and after that, I will show a video explain how it's work and how it's made. Now, let's start our presentation. In Epiphany in Pisa, 1583, the story starts with a young Galileo Galilei studying at the Cathedral of Pisa. He noticed a hanging calendar moving back and forth in regular rhythm, even when the movement was small or wide. By using his own heartbeat to count the time, he made an important discovery. The time of each swing was almost the same in every time. The pendulum law, a new way to measure time. Main idea, Galileo experiments showed that the time of the pendulum swing depends only on its length. It doesn't depend on the weight of the bob or how wide the swing is. Why it is important? This idea, called isochronism, showed for the first time that a natural movement can be studied and predictable. Because of this, the pendulum could be used to control clocks and make them much more accurate. The plan for a perfect clock. Although the Galileo never managed to build a complete pendulum clock by himself, he clearly understood how the pendulum works. This understanding helped him design a simple mechanism to use this idea. This drawing shows his idea of using the pendulum steady and regular swing to control the energy movement and make the device that keep the time. The anatomy of a revolutionary machine. Galileo's design relies on several key components work in the perfect harmony. 1. The pendulum, the heart of the clock, providing the regular time path. 2. The weight, the power source, converting potential energy into mechanical motion. 3. The gears, the transmission, transferring and reducing the speed of motion from the weight. 4. The escapement, the brain, translating the pendulum swing into discrete, controlled step for the gears. The heart and the brain, controlling time. The pendulum, the most important part for keeping time. Its length is carefully chosen so that each swing takes the same amount of time, which makes the clock accurate. The escapement mechanism, the most important new part of the clock. It links the pendulum to the gears. It changes the constant ball of the weight into the small regular movement, letting the gears moving a little with each swing of the pendulum. The engine of the clock. The weight is the power source of the clock. It is tied to a warp that's warped around the gear. Gravity slowly pulls the weight down, changes the stored energy into movement that makes the clock work. The gears. This is our toothed wheels that's moving energy from the weight to the clock hands. They slow down the motion a lot, turning the fast drop of the weight into the slow and steady movement of the hour and minute hands. The parts of a modern masterpiece. The result of digital design and 3D printing is a field set of the parts. Even though they are made with a modern materials, each part still matches Galileo's original idea in shape and function. This 400-year-old idea is now a real physical kit, ready to be put together. Assembly, turning a great idea into reality. The separate parts are carefully put together. This process brings together all mechanical idea with the accuracy of the modern manufacturing. The result is a fully working pendulum clock. It's a real object that connects the science and engineering from 400 years ago with today's technology. The time mold principle at play. The mechanism works exactly as Galileo envisioned. 1. Energy storage. The weight is lifted as stored potential energy. 2. Motion regulation. The pendulum swings at the constant rate, providing a reliable time reference. 3. Energy transfer. Through the escapement, the pendulum controls the release of energy from the weight to the gears. 4. Time display. The gears rotate the clock hand at specific speeds. A legacy of precision and simplicity. Galileo clock is special because it's accurate and simple. High accuracy. The pendulum helped the clock measure the time correctly. Mechanical innovation. The pendulum and gears work together smoothly to move the clock. Simplicity. The clock uses a simple mechanical parts that are easy to understand. Historical impact. Galileo's idea helped create a modern pendulum clocks used today. Now, after we finished our presentation, we will move to the video to see how we made the clock step by step. In this stage, we reviewed the designed components of Galileo clock using 3D models. We organized the parts and checked their shape and dimension to ensure they fit together correctly before assembly. At this stage, we started the 3D printing process and carefully monitored the printer to ensure all parts we print correctly and according to the design, especially to avoid any interruption, such as a power outage that could affect the printing process. After completing the 3D printing process, we clean the part by removing extra material and support. In this stage, we put the printed part in the order and we starting putting the clock together. Each part was placed carefully in the correct place. In this stage, most parts in the clock were already put together and flexed in their place. The clock almost finished and the only small part were left. At this point, the clock was ready to be checked to make sure all the parts were working well and moving correctly. In the final stage, we finished putting the Galileo clock together. All parts were in the right place, and the clock was able to work perfectly. And thank you, Doctor, for listening to me these previous minutes. I hope you have a nice day. Thank you.